Okay, so now that we are 40 minutes into this class and we've already gone over the test and we're starting to record, this is now lecture number, what are we, 13 now, I believe, in the 7th week, October 12th, Math 211. And now that we have finished, going over the test, we're going to continue working on the material in the book. So let's find it. What are we in? Chapter 11, I think, maybe 12. I never remember. 12. Okay. So glad that you guys are here to help me with this. We did the mean. Oh, I remember that one.
We're on page 3.
Page 3. I remember this. Well, let's start from the beginning because we might as well start from the beginning of the chapter and review. So I'm going to share my screen here. So, okay, everyone see the mean?
Yeah.
Okay. So we have the mean, we have the average. Okay, so how do you compute the mean? You add up all of the data points and divide by how many you have. We did this example last time. It's not a histogram because these are not numerical data. These are quantitative data. Oh, sorry, they're categorical. They're names. And we don't have, classes of from this number to this number, this number to this number, and so on. And you can make a histogram out of it. We did that. So let's talk now, page 3. If we take that formula that we had here and you cross multiply, you get that the sum of the values is equal to the average times the number of values that you have, which gives us another way of thinking about an average in the sense that if everyone had exactly the average, the total would still be the same. So rather than 5 and 3 and 10 and 6 and 9 and whatever numbers everyone has individually, if everyone had the average, they would add up to exactly the same number. In other words, the total is equal to the number of values times the mean times the average. Another way of thinking about the average. Okay. We're going to skip this class activity because we're not in class, but we can do this one. Actually, I don't think we can do this one either, but it is kind of interesting. So Microsoft Word, if you write an essay, you might have wondered about this historically. If you write an essay on some of these computer programs, it can give you an estimate of the sophistication of your essay by, okay, was this written by a 3rd grader, by a 4th grader, a 5th grader, a high school student, a college student, and so on. And one algorithm, one formula that it uses called the Flesch-Kincaid grade level formula does the following. And I don't know where this formula came from, and I'm not going to worry about it, but it basically says, if you take the average sentence length, which is the number of words divided by the number of sentences. So in other words, on the average, each sentence was this many letters, and you multiply it by 0.39. And you take the average number of syllables per word. So now we're looking at every single word and the number of syllables, and we divide the number of syllables by the number of words, and we multiply that by 11.8. And then we subtract 15.59. This gives you your grade level, or your grade level of the text. In other words, you're writing at this level. So let's actually do it for this sentence here, the last 3 lines of the page. Let's compute the grade level. First, before doing any math, I want you to read these 3 sentences and then tell me, who do you think wrote it? Elementary school, middle school, high school, college, or professor? Or advanced. And I should load up the text so I can see people writing. Okay. So I have no answers yet, so I'm still waiting for answers.
Wait, do we read the bold?
Yeah.
Oh, okay.
3 bold letters, sentences.
And we do the math, or is it?
No,
Is it just
don't do the math. Just first get an impression of what you think.
Oh, okay.
High school, someone said, okay. Nobody else has an opinion? Junior college, college students, okay. Okay, so I have one high school, one junior college to differentiate that person from the rest of the college, and then college graduate, someone who's actually graduated college. Okay. So let's go ahead. Oh, another high school. Nobody said third grade, huh? Nobody thinks this was written by elementary school? No. Okay, well, let's go ahead and compute what the Flesch-Kincaid grade level formula would be. First, let's compute the ASL, which means we have to compute how many words and how many sentences. And we'll need words twice. We'll need it for the ASW as well. So let's get words first. How many words are there? Okay, I think I have the answer, but I might have miscounted. So
40.
how many?
40?
So I got 42.
Yeah, I got 42.
I got 42. But it is really easy to miscount. But if 4 or 5 people got 42, I'm going to say it's 42. So now we need the number of sentences. How many sentences are there?
2.
This one's a little easier. There's 2 sentences. So what is the ASL? What's the ASL? 21. It is the number of words divided by the number of sentences. In other words, the average sentence length is 21 words per sentence. Now we need the average number of syllables per word. So we have to compute the number of syllables. All right, so let's do it.
If I'm not mistaken, there is 68 syllables.
So I also got 68. Now, the word
I think I got
average.
like 71. I don't know. I lost count kind of.
Okay. Oh, yeah, you got me snoring in there. All right, so I got 68. I think ballpark, as long as we're in the same ballpark, it's okay. Okay, so what is the ASW?
Would it be a decimal?
It'll be decimal, yeah. Or you can keep it as a fraction for now.
So it would be 68 over 42, right?
68 over 42.
which is like 1.6 something.
Yeah, about 1.6. Okay, so let's compute now where we have these two numbers. Let's compute the Flush-Kincaid grade level formula. So what do we get as our final answer? I did the math already. What do you guys get?
11.48.
What do you get?
11.48.
So I got 11.7. Maybe because did you use 11.6 here, or did you use 11.6 or 1.619047619? What did you use at that point? Hello?
Well, I got 8.19 plus 18.88 minus 15.59. Then I added the 8 point that.
No, but I'm saying at the ASW, did you use 1.6 or did you use 1.619047619? Because when I yeah, if you just use 1.6, you're using an approximation, which could be pretty significant. Let me do it that way. Yeah, if you just use 1.6, then you get 11.48. But it's not 1.6. It's approximately 1.6. And you want to, and this shows you it's not off by that much. 11.48 to 11.7 is only about 11.2 off. But you always want to use, when you're doing calculations, you want to use as exact of a number as possible until the very end of the problem. So either way, whether it's 11.48 or 11.7, we're basically getting that this was written by someone who's a senior in high school, essentially about 12th grade. Some people guess college, some people guess high school, but I think we all agree that this is at least ballpark correct, right? Yes, no, maybe so. Oh,
Yes.
yes, right. So so this actual statistic out there in the world uses averages. I think the point of this was just to show you that averages are used in places that you might not even expect them to be used. Okay, now models for the mean. The mean is a 6th grade California Common Core state standard. So 6th graders are assumed to have to know what a mean is. The mean measures center in the sense that is the value that each data point would take on if the total of all the data values were redistributed equally. This is what I mentioned earlier, right? It's the value that if everyone had the same amount, you get the same total. Okay, it's a redistribution of wealth type situation. And then also there is the balance point interpretation. The balance point interpretation is if you make a histogram of your data and you balance your histogram, you literally build it like a wooden model of the histogram and you balance it on one finger. Where would the balance point have to be? That is the location of the mean. So you find the location of the balance point, that's the mean. Do both of those make sense?
Yeah.
Yeah.
Okay. So we've talked before about the balance point interpretation. So let's look now at the equal redistribution interpretation. So it says, example, a class of 3rd graders sat at different sized tables. They noticed that the 4 students at the green table had a lot of brothers and sisters. To help the students quantify this observation, the teacher asked each student in the class to take 1 cube for each brother or sister they had. The students at each table put all of their cubes in a pile and then redistributed them so that each student had the same number of cubes. At table green, each student had 5 cubes. Remember, there's 4 students there. So there's table green, there's 4 students at table green. Each student had 5 cubes with 2 cubes left over. So first, which part of the process represents adding all of the values? Which physical step here was adding all of the values?
The end.
The end. What is the
Where
end?
it says each student had 5 cubes and 2
So
cubes.
if each student had 5 cubes, how is that adding all the values? That's a result that you get after you've added all the values.
Would be when they put all
Put
of
it in
the
the
cubes.
pile.
Yes,
Yeah.
yes. Putting all their cubes in a pile, that's the adding. That's getting the total value. Does that seem reasonable?
Could you argue that the redistributing so that each student had the same number of cubes as well? Because you're kind of adding to make sure that each student has the same number of cubes.
But redistributing them is not an adding process.
Oh, for the
Adding is getting a
total.
larger value, huh?
Yeah, okay.
Okay, now, which part of the process represents dividing by the number n, number of students?
The redistributing.
That's the redistributing them, so that each student had the same number of cubes. Essentially, it's getting the quotient. If I say, what's 22 divided by 4, right? What is 22 divided by 4? If you're in 2nd grade and you're learning remainders, or 3rd grade, whatever it is,
5.7.
it's 5,
Oh, remainder 2.
remainder 2. Right? There's 4 students. Each one gets 5 cubes. There's 2 left over. Therefore, there must be 22 cubes to begin with. Right? So which part represents dividing by the number n? That is giving 5. Each student has the same number of cubes. That's 5. Now, what arithmetic skills do students have to solve this problem? Do they have to know the division algorithm? In other words, do they have to know how to divide? How to add? If not, what then? What do they need to do this? And the answer is, you don't really need to know how to divide or add. How hard is it to take all the cubes, put them in a pile, and then give 1 to each, and then 1 more to each, and then 1 more to each, right? You can do math, or you can do things that underlying them are mathematical without realizing that you're actually doing math in the first place, right?
Yeah.
Right? That's the idea. Like, you don't need to know how to add and to divide to split up all these cubes equally. But at the end of the day, you are actually doing math. It's a trick that we use to get people to do math. Don't tell anyone. So if the siblings of the students at table green were redistributed equally among the 4 students, each would have blank siblings with blank left over. What are those 2 numbers?
5 with 2 left over.
5 with 2 left over. It's just nothing new there. It's just repeating what we said earlier. 5 with 2 left over. Does that make sense so far? Yes, no, maybe so?
Yeah.
Okay. Now, the Robin Hood method. Who doesn't like Robin Hood? Except for, the sheriff of Nottingham. But everyone else likes Robin Hood, right? Okay. So a second model for illustrating the mean is illustrated by the following example. Again, the mean is the amount each person would have if values were redistributed so that each person had this equal number and the total remained the same. So here's an example. The 4 children at table green were asked to take 1 penny for each brother or sister that they had, and they arranged them as on the following page. So Justin, Sophia, Carlos, and Alia, 5, 10, 13, 18, 22. Okay, so that's how many siblings each one had. Yeah, okay, so. The teacher asked them to level out the towers of pennies so that they were the same height, removing any extra pennies. How would the towers look after the children finished? If you were to level this out, what would you, what would you do if you were leveling this out?
Give Sophie, give one of Sophia would give one to each person.
To each person? I don't think so.
No?
Just
Or-
tell Leah, and then the other two would have to go.
Yeah, there's not enough to get
Oh,
one.
yeah, one and then two left over.
Right, right. So Sophia would have to give one to Aaliyah, and then the other two would, be taken off the page. Okay, this is the Robin Hood method. I guess the rich give to the poor. So the one who has more gives to the rest so that we're all equal. That's the, I don't know anything about politics and whatnot. Is that socialism? Like we all should be
I
equal,
thought communism.
or is that communism? I don't know. I thought they're the same thing. I don't know.
Yeah, probably.
I don't know. Capitalism, communism, socialism, Marxism,
Darwinism.
anarchy, it's all the same, huh?
Darwinism.
I think Darwinism is something else. I'm pretty sure about that one.
That's evolution.
Yeah, that one I'm pretty sure is something else, but the rest of them are the same. Okay, so now we have the mean as the balance point. We've already done this before. Another interpretation is the balance point. If you were to literally build this contraption physically, like the picture there, and balance it, the mean is the point where you would place your finger to balance it. So here's how one teacher illustrated this idea. Let's see what we have here. We have a 6, a 9, a 3, a 2, a 4, and a 6. So she built this thing and she put a weight at a 2, 3, 4, 6, and 9. And then she had to put this whole thing hanging from one peg. And the question was, where was the location of that peg so this thing did not tilt one way or the other? And apparently the peg was placed right at 5 and nothing tilted one way or the other. So we have the balance point being 5, the mean being 5. And then when you actually do the math, 6 plus 9 is 15, plus 3 is 18, plus 2 is 20, plus 4 is 24, plus another 6 is 30. And if you divide that by the number of objects, there's 6 of them, you do in fact get 5. Pretty cool. Make sense?
Yeah.
I hope
Yep.
so. Another example, the dot plot below gives a number of brothers and sisters reported by 12 second graders. So we have 5 people had no brothers or sisters. How lonely. 4 of them had 1, 2 of them had 2, and 1 of them had 4. It says compute the mean and mark it as the balance point of the distribution. Compute the mean and mark it as the balance point of the distribution. So let's first compute it. How do we compute the mean mathematically? All these tricks that we're learning, this redistribution of wealth, the balance point, they're all nice. But at the end of the day, the easiest way to compute the mean is just to compute it. So how do I compute the mean here? Maybe he has the answer. You ever think of that? Do you speak dog?
He wants to go out. That's what he wants.
Yeah, but I want to go out. I'm not barking.
Yeah, right. Would you? Seems too easy, but 12 divided by 4.
I guess it was too easy because that's not the correct answer.
Oh,
Why do you pick 4?
Oh, I guess that's just the number of siblings. Doesn't really matter.
Well, the number of 4, those are the possibilities. By the way, there's 5, 0, 1, 2, 3, 4. So really 5. But that's not the number of data points. How many data points are there here?
12.
12. So whatever else happens, we're going to be dividing by 12. You always divide by the number of data points,
Oh,
right? The question is, what is the numerator going to be?
would it be 5?
It would not be 5.
Ah.
So what are the 12 numbers that we're going to add together? Because remember, you add up the 12 data points and then divide by how many data points. So if there's 12 data points, we have to be adding 12 numbers.
So we're gonna be adding 0, 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, and 4.
Okay, those are my 12 numbers. And when I add those 12 numbers, what do I get?
Give me a sec.
Okay, I'll give you 2 secs.
Do we get 12?
We do get 12, and therefore, what's
Okay.
the mean?
1?
1. The mean is 1. X bar is equal to 1. Now, that's what the math gives us. Let's see if that works for the balance point approach. If 1 were truly the balance point, then that means that everything right or left of it should balance, correct? Should be the same weight on either side. Now, this one down here, let's use a different color. So how do I, oh, here we go. So this one down here and this one down here are each 1 unit away from 1. So they certainly balance each other, correct? Hello, anyone there?
Yeah.
I mean, do we agree? Does it make sense?
Yeah, we agree.
Okay. And then the next one here balances that one there. Do we agree?
Agree.
Okay, and of course, the 4 that are actually at 1 don't need any balancing. They're right at the right location. So what we have to worry about then are not these guys, those are not problems, and not these guys, those are not problems. And not these guys, those are not problems. But it's the remaining 3 here and the 1 that we have here. And a way that we can balance it is if you move it 1, 1, 1. That's like moving it 1, 1, 1. And therefore, by the balancing approach, you can get them all at the 1 location with equal number of moves to give an indication of why the mean, the balance point is at 1. Yes? Does that make sense what we did? Hello, anyone?
Yes.
Does that seem reasonable, logical?
So because there's 3 data points on the 0, it's equal obviously to like moving that one 3 times.
Yes, exactly. So each of the 3 data points on 0, 1, 2, 3, that's 3 moves. And then the one at 4, I also did 3 moves. I got it to 3, then to 2, and then to 1.
Gotcha. Thank you.
Sure. Okay. So here's another one. 9 students were asked how many blocks they lived from their school. And their answers were 1, 3, 4, 4, 4, 5, 7, 8, and 9. First, it says verify that the mean number of blocks is 5. How do we do that? Well, let's do the math. First, what am I going to divide by? Because that's always the easier one to calculate. What am I going to divide by?
9?
9, because there's 9 data points. And then what am I going to add to that?
1, 3, 4, 4, 4, 5, 7, 8, 9.
So are those commas in between those numbers? What do those numbers mean that you just gave me?
They're they're the data points.
And therefore, what do I do with those 9 data points?
I thought we added them in the previous one.
But you didn't say anything about adding.
Oh,
You
sorry,
said
sorry.
1, 3, 4. We didn't tell
Oh,
me
I
what to
thought
do
you
with
asked
that.
what we were adding, so I just listed the numbers. We were adding.
No, well, okay, fair enough. I didn't say that. I said, what, where do we get? Okay, I don't even remember what I said, but I don't think I said adding. But I'm glad that you know that it's adding. So we're all happy. Okay, so when I add them, what do I get?
45?
45. And therefore, what is the mean?
5?
Okay, so we just verify that the mean is 5. It says mark the location of the mean beneath the number line. Okay, so here's 5. This is the balance points.
I think that's 4.5.
Oh, yeah, you're right. Okay, there were my twos. Okay, so here's 5 right here. Okay, so let's see if it's balanced. Obviously, this point right here is at the balance point. I don't gotta do anything with it. These 3 each gotta go 1 over. This one has to go 2 over. And this one has to go how much over?
3.
Well, it's at 1
4,
currently,
4,
right?
4.
4. So 4, 5, 6, 7, 8, 9 moves, right? Correct, 9? Hello, anyone?
I'm sorry, Professor. I'm really confused about this method.
Yeah, this is super.
I'm better with the fraction dividing stuff. Moving it is hard.
Okay, so we decided that 5 is the balance point, correct?
Yes.
So just how, if I physically pick up these dots and move them to 5, the question is, what is the total of my movements gonna add up to? So this one's at 4 currently, right?
Correct.
So if I move it to 5, how far did it move?
1,
And how far did this one move?
1,
And this one?
1. So that's a total of 3, right?
And this one? Yes, so far 3. And this one?
Plus 2,
So for a total of?
5 plus 4 is 9.
Okay, so the total motion on this side is 9. Do we agree?
Yes.
Yep.
Now, how far did this one move?
2,
And this one?
3,
And this one?
4,
And when you add those up together, what do you get?
9.
9.
Hey, they're equal.
Oh, okay.
So does it being the denominator have anything to do with?
Well, no. That's a complete coincidence. This 9 here in the denominator was the number of data points. These 9s are the number of movements. Nothing to do with each other.
We're adding how many steps it took us to get to the mean
Correct. On each side.
on each side.
Now, if it really is the mean, you get the same number for each side.
Okay,
If it's not the mean, then you don't get the same number for each side and you're in the wrong spot.
perfect.
So that's just like pretty much like a checking your answer.
Well, this is the idea of the balanced point approach, where every motion on one side of one unit
Oh, is equal to the.
corresponds to a motion on the other side of one unit.
Oh,
And if the total number of units here equals the total number of units there, then we have balance.
There should be
That's the
this.
idea. Alex, does that make sense? Or more sense?
Yeah, it makes more sense.
Okay. Now, what does this balance scale illustrate?
that there is no balance.
Well, okay, the picture's not perfect, but if it's not tilting, if it's not physically rotating, if it's just sitting there in space, then it is in balance. Right? If you ever built something like this or had something like this, it could be like a friction keeping it in place, even if it's not truly parallel to the ground. Right? I mean, the picture is not the greatest picture, but
So it's showing that 6 plus 2 is equal to 8.
it's
Is
showing
that
that 6 plus 2 is equal to 8. Essentially, that's what it's showing. That if you move this guy 2 units and this guy 6 units for a total motion of 8 units on the left, that balances my motion of 8 units on the right. Yes, no?
Yeah.
Yes.
Which is why the mean is in fact right here in the center. Because it is in balance. And we have a ways to go and we're just about done with the class, so we'll stop here. On page 14. Okay, questions on today?
Did what we go over, is that enough to do a couple homework problems?
Well, yeah, I mean, I can't assign the homework yet because we haven't finished
Done
the
with the lesson.
chapter, but you can certainly start the homework and answer probably about half of them.
Okay,
Sound good?
yep.
All right, then, excuse me, if there's no other questions, I will see you guys on Thursday. I'll try to have the test graded by then, but I make no promises because I'm lazy.
See you then.
See you then. Okay,
Thank you.
You.
you're welcome. You're welcome.